is and then the next one is 4y is less than negative 3x. And then the next one is x. This one, I guess we can handle this one. That's our system we're supposed to graph. Maybe down the road, I might show you different ways of doing these. But for now, we just got to all do the same thing. And then later on, if you want to diversify, right, and then find out different ways of doing it, and that's a maybe. It depends on how much time I have. So this one here, I'm going to start with that one. I want it to look like this. 3x, I'm bringing the 4y over just for a bit, and then I'll rewrite it later, and it's going to be less than negative 12. And let's go ahead and find the intercepts just like we've always done. Sometimes they're whole numbers, sometimes they're decimals, not a big deal. 3x is equal to negative 12. Quite often, just to make the example easier to understand, I use easy numbers, and then students do the homework and they're thrown off by decimals, fractions, all of that. Don't let that throw you off. You've learned that. You've learned how to deal with them. It's just to make things a little bit easier while explaining. Okay. And so that's my x-intercept. My y-intercept is negative 4. Y is equal to negative 12. And remember, the intercepts here are dealing with the line. That's why for a little bit, I'm using the equal signs just in that box. Okay. And then it's both divided by negative 4. And that's 3. So that's 0, 3. And I box that in. I will rewrite it under it. And I'm using the previous line. I bring the 3x over, minus 12. I divide everything by negative 4. Warning, warning, right? When you do that, and you're dealing with inequalities, you need to make sure you take care of that. Double check your signs. One quick look back. So, okay, negative is positive, right? These two negatives give me a positive. Two negatives give me a positive. We're good. And so I'm just going to say that this is a dashed line. The true region is above. The shading is below. And so we're done with that. And if you feel more comfortable, put a wall there. Right? Block that off, and then we're on to the next one. This one is tricky. I'll bring that over just to show the point. So that 3x comes over positive. The 4y is already there. And then it's less than 0, right? So what's my intercept going to be for both of them? It's going to be 0, 0, 0, 0, right? I will go through the motions here, because sometimes when I just jump to conclusions, students are like, how come? Like, what do you mean? 3x is equal to 0, divide both sides by 3, x is equal to 0. There's nothing you can do about that. Alternatively, 4y is equal to 0, divide both sides by 4, y is equal to 0. Okay, so now I think you can see the point. So this one, folks, doesn't help you. You don't have two different points, right? They're both the same. Can't graph it, right? 0, 0, connect 0, 0 with 0, 0, you're not moving. So this is what you need to do with this type. you need to find a second point. We can use up a little bit of room here, so it's okay to go over because that one will not need any space, really. You need a second point. This is how you do it. I will rewrite it, okay? The best way to do this one is to rewrite it. So I'm going to go up top there, and it says 4y is less than, bring the 3x over, and then divide it by 4. You need to do that, right? Y is less than negative 3 over 4 x. This works best if you have rewritten it already. So you can make x be anything you want, and it will give you back a y value. Because remember, this is a relation, right? So if you say, hey, if x is equal to 2, what would y be equal to? That's what you're asking here. What's the smartest value to pick? This is IPR stuff. What's the best value to pick here for x? Because you have that 4 down here. Multiplied by 4, yes. So let x equal to 4. And then so you go y. For a moment here, I'm going to turn this into an equal sign. I'm going to forget about the inequality. I'm just going to go negative 3 over 4 times 4. And this cancels out. Y is equal to negative 3. So you just found a point, a second point I might add for negative 3. That's what you just found. Sometimes it's easier to just pick x equal to 1. Sometimes, in this case, I chose 4, so I could cancel out that denominator of 4. So how about this? We do this. This is an aside here. It only needs to be done every once in a while when it's something like this where you both have both zeros. So let's, this is my second point. Now you have 0, 0, and this point we just found to connect. So now you're in business, right? Let's do this. This one is already done. It's a vertical line because Mr. Dirksen says so. No, I want you to know that, right? So I'm kind of flying through it, but it's x, right? X is a number, vertical, right? Oh, you can see. There, sorry about that. X is a number, it's a vertical line. And in this, it's all cleaned up already. X is isolated, so it goes through negative 4, 0. And we're just going to say that this one is solid. The true region lies to the right because it's x greater than. So I'm going to shade to the left. And half of you are thinking of the song, Beyonce's song, right? To the left, right? Maybe not. I don't know. Did you grow up with Beyonce? I don't know. Maybe I'm off. Anyways, kinda. Yeah, she's kind of like, yeah, she's bridging that gap there. Anyways, back to this. I forgot something here. So this one is a dashed line. The true region is below, and so we have to shade above. Sorry, but I forgot to do that. That's just me trying to get to the graph, I guess. I really want to get to that graph, so basically we've done everything we do every time with all three. Now it's time to graph. I will do this first though. Grab your calculator, type them in first. Because when you do 3, let's just put it this way, things can go wrong. Would you agree with that? Things can go wrong. So Let's put it in the calculator first so we have an idea before we plug it in. So you beat me to it. You're better at typing than me anyways. So that's one thing you have already as an advantage. You remember how to do vertical lines? 999, 999, 999. And it's x what? X plus 4, because you're trying to graph minus 4. If you do 10 nines, it's okay, but 9 I think is the minimum to get it right. I don't know why it works, but it works. We used to always be told you can't do vertical lines. Now we can. Okay, so then hit graph. There's the first, there's the second, and there's my third line. So that's kind of what we're expecting, okay, if everything goes well. So now I have an idea. I'm going to go and graph I'm going to make my grid. This is going to be it. The grand finale. And you need to pick your scale. I think if we go 5 in each direction, we're fine. So I'm going to go 1, 2, 3, 4, 5. Same thing. And the positives. I'm going to try 4. X and Y. And let's graph this. So the first one is -4, 0, 0, 3. That one is a dashed line. I'm just looking at my notes, okay? So this is the line y is greater than 3/4 x plus 3. The next one is 0, 0, and 4, -3. So 1, 2, 3, 4, -3. That is dashed as well. I better get this right. If I get this wrong, I don't have time to make it up. That's that one. And the last one, x is equal to -4. It goes right here. And that one is a solid line. Is it less? Oh no, it's greater than. Sorry, greater than or equal to a -4. And now you're shading. The first line says to shade below. So this line is below. Make sure you get the graph. So everything below it is gone. The second line says to shade above. So I'm going to do that. We have 6 minutes still. I'm looking at my clock here anxiously. The other one says shade to the left. And your solution region is actually completely closed in from all 3 sides. So this is my solution region. That is the unique part about 3, that this can happen. Okay? It is possible to have it completely closed in, not always. And let's find the POIs together. I want to do the POIs together if at all possible. So grab your calculators. I want to find this one here, okay? I'm choosing to find this one first. So I'm going to turn off the vertical line for now. So let's go to y equals. Just go to the equal sign and hit enter so when you move away, it should not be selected. Then you hit graph. So now it's only going to graph those two that you're interested in. Got it? Then I'm going to go second trace 5, enter, enter, enter. And it's -2, 1.5. Got that? Now I'm going to go y equals, turn on the vertical again, hit graph again. I want to now show you how to do it when all three of them are present. Ready for this? You have to be careful here. So second trace 5. Which line are you on right now? You're on, look up here, you're on Y1. So you go as close as possible to that intersection you're interested in by going arrow to the side. I don't know if you can see it, but my cursor is right there. I'm going to go close. You don't have to be right on it, just close. I'm interested in this intersection right here. And then you hit enter. And where are you now? Y2, right? But we want to be on Y3. So go arrow up. Now you're on Y1. Go arrow up one more time. Now you're on Y3. Once you know that you're on Y3, you can hit enter, enter, enter until it finds that intersection for you. And it's -4, 0. So your arrows up and down jump line from line to line to line. Okay? One more. We got to find this one up here. Just follow my lead here. Second trace 5. I want to be on the diagonal here. So watch what I'm going to do. Arrow up. Arrow up. Now, if you go sideways, you're actually on Y2. You're on this line. Hit enter. And it just happens to jump to the Y3 after. So it's asking. So now I hit enter on Y2, right, on that line, and then it jumps to Y3. Then you just hit enter, enter until it gives you that. All right. So I know the bell is going to go. So this is the only homework you have. Page 4 and 5 in your work booklets. I would suggest you do it on loose leaf. I give you like a grid, but I would say do it on loose leaf. Don't do it on there. It gets a bit messy. So page 4 and 5. Thank you guys.